In this lesson we'll talk a little bit more about the least common multiple, but this time we'll look at finding the least common multiple of 3 numbers instead of just 2. So I'm going to show the first example here in 2 different ways you could do it. You might look at 6, 10, and 15 and say, you know what, these numbers aren't too incredibly large, so maybe I will try the list method, where I take the largest number, look at multiples of that largest number, and then see if the other 2 numbers also divide into that multiple. So first of all, we can already tell 6 does not go into 15 evenly, and neither does 10 for that matter. So then we could bump 15 up to its next multiple of 30. Does 6 go into 30? Well, yeah, 6 times 5 is 30. Does 10 go into 30? Yes, 3 times 10 is 30. And so just by making this list and saying that yes, the other 2 numbers do divide into 30 evenly, we've got our answer. Okay, but it's important to remember the other strategy as well, because like I said, the bigger the numbers get, the more you'll want to do this prime factoring strategy. So I'll prime factor each number, and we'll recognize that the least common multiple is the product of the different prime factors we see raised to the highest number of times that prime factor shows up for a number. So 2 appears once in 6, once in 10, and 0 times in 15. So all I need is 1. Right? Because the 1, 2 from the 6 can fit into the LCM with just 1, 2. The 1, 2 from the 10 can fit in with just 1, 2. 3 appears once in 6, 0 times in 10, once in 15, so I only need 1 of those. And finally, 5 appears 0 times here, once in 10, once in 15, so I only need 1 of those. And if I take this product, 2 times 3 is 6. 6 times 5 is 30. Of course, we get the same exact answer. Now, these numbers here are much larger, and so I'm more inclined to go with the prime factoring method right away for these 3. The list may or may not take me a long time to accomplish, but I really don't know that ahead of time. And so I'm going to just do the prime factoring method. So I'll prime factor each of these. So 21 is 3 times 7. 30, remember, it doesn't matter how you break these down when you prime factor, you'll end up with the same prime factorization in the end. And so this is what we have right here. So I've got 2s, 3s, 5s, and 7s involved. So then the only question is, do I need to raise any of them to a power? So 2 doesn't appear in 21. It appears once in 30, and it appears once in 54. So I just need 1, 2 in my least common multiple. So we're good there. 3 appears once in 21, once in 30, but then it appears 3 times in 54. So I need 3 of these 3s. Right? So now 54 with its 3 factors of 3 will be able to fit into this number I'm creating. And again, I don't need to add up how many 3s I have, because if I've got 3 here, certainly 1 3 will fit in from 30 and 1 3 will fit in from 21. That's not going to be a problem. 5 appears 0 times in 21, 1 time in 30, 0 times in 54, so I just need 1. And 7 appears once in 21 and not the other, so I only need 1 7. So this is going to end up being a fairly large number. 3 times 3 times 3, which is what 3 cubed is, right, is 9 times 3, which is 27. So this is 2 times 27 times 5 times 7. And 2 times 27 is 54. So I've got 54, and then 5 times 7 I know is 35. And so now I've got to multiply 54 and 35. And so I end up with, looks like 0981. So 1,890 is my least common multiple. And I'll tell you what, I'm pretty glad that I did not decide to do the list method here, because it would have taken me quite a while for 54 to build all the way up to 1,890.